Good morning. My name is Brian Carney. I'm a professor of civil engineering at University of Toronto, and I'm speaking to you from Toronto. Toronto at the moment is a very wintry city, but it's a shame that I'm not in Dubai. I was very much looking forward to this trip. It was something that was on my schedule, but I was in Costa Rica a couple weeks ago and I broke my ankle, and that's made it a lot more difficult to get around, and it means I'm communicating with you in this much less than desirable way of doing it, but I very much send my best greetings and my wishes to you from Toronto to the conference in Dubai. I'm going to talk to you for a few minutes about water supply infrastructure and really the way we support cities. I thought of doing a PowerPoint, but I thought I'd just talk to you instead and try to give a bit of an overview and a bit of a summary of some of the key things that one can say about this particular topic. I think one of the things that is interesting about being on crutches, as I am at the moment, is that you realize how many things you take for granted. That is, the simple things of getting around, of movement, of getting from the house to the car, or getting from the office to a lecture, all of a sudden become much more difficult. I think infrastructure is a little bit similar in the sense that we take it for granted unless it starts to fail. And when it fails, we often have great complications associated with that infrastructure. We undervalue it, and yet it facilitates so many things. And that really is a challenge for us. When we don't have infrastructure, we're willing to invest. We're willing to put more effort into it. But when it's functional, we tend to take it for granted, and it tends to have periods of presumption, periods where it languishes. And we have to be reminded again that it's important. And I think that leads to a sort of a natural cycle of investment and then presumption, where eventually we wake up and say, this is important, this matters. One of the things that I think we sometimes forget as people who do infrastructure is really the foundation of our healthcare system. That is, having clean water, having water that's reliable and readily available is one of the key things that allows us to stay healthy. Without that, hospitals are in emergency crisis situations. Without proper infrastructure, we end up with cities that don't function well or fires that cannot be fought. And so this is a crucial area. It's an area that undermines not only the functions of cities, but really the functions of people within cities. And really, people, of course, are what makes cities matter. So that's one of the key messages, I think, is that we've got to wake up again and value this thing, which provides so many services to us as human beings, to the industries and to the commercial operations that are part of our cities, and to, of course, the infrastructure itself, which plays such a crucial role. One of the things that is particularly fascinating to me is that we as infrastructure experts or professionals often communicate very poorly, I think, what infrastructure does and how to support it. So many times, at least in my experience, when someone comes to an infrastructure specialist, a water supply or a transportation specialist, and they sort of say, yeah, infrastructure is important, we've neglected it for a while, it really matters. So often we end up saying very simple things like, trust us, the infrastructure is important, we need to invest in this. And I think one of the things that we have to do, one of the revolutions that's needed in this area, is in fact the need for having more effective arguments about why infrastructure is important. A number of years ago, my wife went through a period of time where she was under treatment for cancer. And there were several options in the treatment for that cancer, and the options were not perfect in the sense that if you did one thing, there was a certain chance that that would cause complications, but there was a reduced chance that the cancer would return. If you did something else, there would be fewer complications, but there would be a higher chance of cancer return. Everything was couched in terms of probabilities, in terms of the likelihood of making things turn out properly. There was no guarantees. And I think in our infrastructure, we so often still want to live in this false world of determinism. We want to set up a world which has things known for sure. The reality is that the water supply system, as one example, will have failed pipes. And what we can do by better and more effective investment is we can reduce the probability of those failures. What we can do by better management is we can reduce the chances of upsets. What we can do by a better holistic design for our systems is make these systems perform better on average. But it means that we need better metrics. We need not just a whole-scale appeal that says this is important, trust us. But we need an argument that says this level of investment will lead to this frequency of problems. And this increased level of investment will drastically reduce the probability of those problems. And that would be true for health upsets in terms of contaminated water supply systems. It would be true for pipe breaks and disruptions of household water supply and fire use and transportation systems, because everything's interconnected. But I think it's about time that we woke up and said we need to communicate effectively just how levels of investment are tied to levels of performance. And we haven't done that as well as we should in the past. And so I think one of the things that we need to do is we need to monitor the systems much more carefully. One of the images that's been in the back of my mind as I've thought about this area of infrastructure has been the idea of a sea change. A sea change comes, of course, from navigation. The idea that sometimes you look at the ocean and it's calm and everything's beautiful and picturesque. But in a short time, a storm can brew up and everything can change. It can go through a sea change in terms of its performance. And it can do that both from calm waters into turbulent waters and also from turbulent waters back into calm waters. The storm can pass. One of the things that sea change comes in, I think we're in a sea change that's taking place right now with respect to the way we think about these critical infrastructure systems. Historically, we've tended to think about building new systems. Now, much more, we have to think about systems that have to be rehabilitated, have to be rebuilt. And in fact, where we're mostly doing system expansion as opposed to design from scratch. And that is a very significantly different challenge. It means that we have much more data about the current system performance than we had in the past. But it also means that we have to be much more clever about thinking through the challenges of existing systems, of thinking why they're not performing well, what would be a strategic investment to make them perform better. In individual systems, we've done a fairly good job of this. But for the system as a whole, for the way it interacts with other infrastructure systems, for the way we invest in it, for the way we use computer data, we're just at the threshold of a new way of thinking about things. Another aspect of the sea change, I think, is almost implicit in the name sea change itself. Sea change implies a dynamic system, a system that undergoes transience. Many times in the past, we've tended to think about these systems as primarily static systems, that they sort of have a fixed job and they go about doing that. I think more and more we've realized that these systems are dynamic in almost every capacity or every aspect of the system performance. The hydraulics are dynamic. The water quality issues are dynamic. The system capacity is dynamic. The expectations of humans are dynamic. The way the system evolves over time is dynamic. And we need to have that time element more effectively built in, where we're not just building things and forgetting about them and then being reminded, as we talked about at the beginning, but in fact where we're constantly monitoring systems and constantly making minute adjustments, where we're constantly reevaluating what the system can do, what it should do, and what it's capable of doing, and what the next level of investment will bring to the system. There's one other challenge I want to leave with the audience and way of closing, and that's the challenge associated with intermittent systems. There's a great many places in the world that don't have continuous water supply. Those intermittent systems where water is supplied only part of the time, I think have tremendous issues with respect to their performance. They stress people, they're not equitable. Often the rich people are able to get better systems. It puts a lot of the expense onto the homeowner, where you have to duplicate systems that should have been provided in the original water supply system and can often be provided more economically. A great many people who are living with intermittent systems are so used to them that they become complacent. They sort of can't imagine anything different. But the reality is these systems are problematic in terms of the performance, economically, hydraulically, and water quality wise. And so I think one of the millennial challenges that we need to take on in the infrastructure system is we need to figure out ways of removing intermittent systems from the repertoire of the way we supply water. I think there's better ways of doing it. And I think this is a problem that with our current level of creativity, with our current level of capacity, with our current understanding, we can solve. It's just a matter of, do we have the will to make a difference? I wish you the best for the rest of the conference. I hope it's a terrific and wonderful experience. And again, my apologies that I cannot be there in person. Thank you.